In this example, we're going to solve this linear system using elimination. So the first step is to go ahead and write both of these equations in standard form. So the x and the y need to be on the left, and that needs to equal the constant. So this positive 11, I'm going to bounce over to the right, and this 3y I'm going to bring over to the left. So negative 7x, and the 3y will become a negative 3y. And this positive 11 will become a negative 11. So the first equation is written now in standard form, xy equals a number. And the second equation here, there is no constant, so I know that's just going to be a 0. So I'm going to add 10y. So I have 5x plus 10y equals 0. Okay, so I'm going to write little bars here for the elimination. So let's inspect the variables. So I have x's and y's. The x's do have opposite signs, and the y's have opposite signs, but the 7 and 5, they're not the same numbers, and they're not factors of one another. And same with 3 and 10, they're not the same numbers, and they're not factors of one another. So I'm going to have to ultimately multiply both equations by an integer factor in order to eliminate one of the variables. So let's go ahead and do the y's. So 3 and 10, so they have opposite signs already, negative and positive, so we're kind of good to go. So I'm going to bring this 10 up here, and this 3 down here, and I'm just going to go through and multiply. So 10 makes negative 70x minus 30y equals negative 110. And then the 3 comes through as 15x plus 30y equals 0. So when I add these equations up, my y's will cancel. And again, that was the hope here. That was what we were trying to do. So negative 70x plus 15x will be negative 55x. And that equals negative 110. So when I divide both sides by negative 55, I get x is 2. So once I know what that value of x is, I'm going to go ahead and plug it back in up here into one of these equations. And let's go into the second equation. So 5x, so 5 times 2 equals negative 10y. So 10 equals negative 10y. So when I divide by 10, it looks like my y is going to be negative 1. So now that I have values for both my x and my y, I'm going to write the solution as an ordered pair 2, negative 1. And this ordered pair then is the solution for this linear system.